Before starting any of your processes, you need to ensure that you've undertaken hand decontamination through hand washing and that you're wearing all the required personal protective equipment that is appropriate for the task you're about to undertake. These will be listed in your standard operating procedures and will include items like lab coats, gloves, goggles, and masks as needed. Once you've finished with the hand wash and put on your PPE, you'll need to prepare your work areas. This includes taking out any of the consumables that will need to be brought to room temperature, as well as cleaning down your workspace. You'll also need to do things like prepare discard pots that contain 10% bleach. Your workspace must be cleaned at the start and end of every day, as well as in between changes of procedure when you'll be working with different specimen types. The same process will also need to be undertaken if there are any spillages. For fluid spillages, you'll need to follow local guidelines, as there may be additional steps that you're required to undertake. Preparing and cleaning down of your workbench includes not just cleaning down the bench space itself, but any of the equipment you're likely to use, including racks and pipettes. We're now going to look at how to read an antibiotic susceptibility test. When you remove the plates from the incubator, record the temperature, as well as ensure that they have been in the right type of incubator, i.e. 5% CO2 for Streptococcus pneumoniae and a standard incubator for E. coli. Ensure that you always read the matching control plate at the same time as you read the specimen test plates. The control strain should be sensitive to all antibiotics tested. If there are any discrepancies, record this and repeat the assay. Record results as R for resistant, S for sensitive, or I for intermediate. Zone of inhibition is less than resistant, but a zone is still visible, according to the UCAS zones of inhibition. When reading the plates, the growth should be evenly distributed across the plate, and inhibition zones, where present, should be uniformly circular. Read the plates with a ruler or a set of caliper. If individual colonies can be seen in the bacterial lawn, the inoculum is too light and the test should be repeated and not read. Ensure the inhibition zones on the control plates are in the parameters stated in the SOP. If not, then the testing for all linked specimens must be repeated alongside setting up fresh control samples. If repeated failures happen, the process will require troubleshooting, i.e. checking disk activity, checking control isolate functionality, and reviewing incubator performance. Once the quality measures have been completed, you can then move on to measuring the specimen plate zones. For all agent zones, you should be measuring at the point of complete inhibition, holding the plates 30 centimeters away from you, and tilting the plates back and forth, as this helps to better differentiate where the inhibition zone finishes, as well as supporting the identification of mixed cultures by helping highlight different colony morphologies. Read supplemented plates, i.e. blood agar with NID, from the front with the lid removed. Other plates should be read from the back, with the lid intact. Do not use transmitted light, i.e. plates held up to lamps or other direct light, or use a magnifying glass, as both of these can impact on the read quality. Interpret zone diameters by using either a reading template or by measuring with a ruler and using the breakpoint table depending on what you have available. Measuring with a ruler the zone size. If the zone of inhibition is not fully circular, measure the radius from the centre of the antibiotic disc to the closest area of inhibition, i.e. the shortest distance. Small colonies that are visible should be taken into account when reading the zone. Weak colonies growing within the zone of inhibition, i.e. intermediate or resistant colonies, should be subcultured, identified, and then test repeated if necessary. Antagonists in the medium may result in faint zones up to the disc. Such zones should be ignored, and the zone of inhibition should be measured to the point of clear demarcation where there is an edge of clear growth. Some common issues in terms of reading. If there are small colonies present near the edge of the zone of inhibition, then it can be due to the presence of excess humidity in the Muller-Hinton agar and linked to plates not being sufficiently at room temperature prior to plating. In this case, the plates will need to be reset up to permit accurate reading. If the growth is too light, i.e. individual discrete colonies are visible in the bacterial lawn, then the plate will need to be repeated. Isolates may appear unusually resistant if the inoculum is too heavy. If the control strain appears resistant, then this may be the reason, and all associated test samples will need to be repeated. For individual test samples, they should be compared at reading with the density of control plates. If the density of the test sample is greater than that of the control plate, the test should be repeated, as isolates may be read as falsely resistant. The same premise is true for over-incubation of test and control plates. If the control samples appear resistant when they should be sensitive, it may be due to extended incubation, and all test and control samples should be repeated. Plates should not be read if they have been incubated longer than 24 hours in total, as this may impact the results. If the plate contains more than one morphology, or the resistance profile appears mixed with sensitive and resistant/intermediate colonies, then a purity plate should be made and the antibiotic sensitivity plate repeated from this pure growth. If when reading plates they have become contaminated with fungal or other contaminants, such as bacillus, these are likely to be present around the edge of the antibiotic sensitivity plate and will require the plate to be repleted from a non-contaminated primary or secondary plate. If the contamination is present around the disc itself, this could be due to contamination of the disc or the antibiotic disc dispenser, and therefore action may be required to decontaminate the disc dispenser and/or disposal of the contaminated disc tube. If controls appear resistant when they should be sensitive, this may either be due to a contamination of the control strain or a disc failure. Disc failures could be due to inappropriate storage, expired disc, incorrect placement on the test plate, absorption of the antibiotic into the agar itself. The first step is to repeat the test and then to troubleshoot by checking the agar discs themselves against a panel of isolates with known results and the batch details. If the problem continues, then that lot should be disposed of and a new lot accessed. It's crucial that when you're recording your sensitivity pattern, you record what your zone sizes are in your lab book. This needs to include what your plate IDs were, what your organism IDs were, what the zone sizes were, as well as whether they were resistant, intermediate, or sensitive, what your control sample zone sizes were, and also what next steps you take, i.e. are you going to set up a further test via an e-test for MICs? You will then need to clean down your bench space appropriately.